Hey everybody, let's jump into chapter 5 today. So we're doing two sections, 5.1 and 5.2. And in 5.1, we've got discrete random variables and probability distributions. So first of all, let's talk about a random variable is a variable whose value depends on chance. And what do we mean by the fact that the value depends on chance? Well, it's just the chance of whichever of these things we're picking. So for instance, let me give you an example. These would give us random variables. So if we look at something, anything that changes. So if I'm talking about how many people in class have brown eyes, well, that's going to be a random variable because it depends on which class it is, how many people are in the class, and obviously from one day to the next, we might have a different number of people with brown eyes. So there's an example. How about if we look at, we pick some random person and we want to find out their weight. So weight of a person. Obviously, what's going to change there isn't necessarily that person's weight, but it depends on who I pick. Two different people will most likely have different weights. And then lastly, let's look at maybe the number of cars in the parking lot. These would all be random variables. So it's nothing real crazy or anything, but let's talk about the name of this section, discrete random variables. So remember what makes something discrete. If something's discrete, it's countable. So discrete random variables, that are discrete. So for instance, and let's say discrete and in parentheses countable. Okay, so the examples I said before, the number of people with brown eyes, we're going to count the number of people with brown eyes. That would be a discrete random variable. The weight of a person, we don't count the weight, we measure the weight. Anything that's measured isn't discrete, it's continuous. And so the weight of a person would be a continuous variable. It's not a discrete random variable. And then number of cars, of course, would count the number of cars. So that's also a discrete random variable. So that's the idea. So random variables, these have to be numbers for random variables. I don't think I put that in the definition, but a random variable is a quantitative or numeric variable whose outcome depends on chance. And did we say that? Let's numeric slash quantitative. Just so that we're clear on that. Okay. All right, so let's go from there. Let's do an example that we have from the book. So this is problem 511. It's called Space Shuttles. It says the National Aeronautics and Space Administration, NASA, compiles data on space shuttle launches and publishes them on its website. The following table displays a frequency distribution for the number of crew members on each shuttle mission from April 12th, 1981 to July 8th, 2011. So notice crew size is going to be a discrete random variable. Obviously, it's numeric. Obviously, we would count them. And so it satisfies all those parts of the definition. And the randomness of it has to do with, well, it depends on which mission we did. You know, there was 4 different missions that had 2 as the crew size, 3 that had 4, etc. Okay, so let X denote the crew size, that's our random variable, of a randomly selected space shuttle mission between the aforementioned dates. A, what are the possible values of the random variable X? So on part A, the possible values of X, they just told us crew size was X. So we just list those, 2, 4, 5, 6, 7, 8. Those are the possible values. We can put them in braces if we'd like to. B, Use random variable notation to represent the event that the shuttle mission obtained has a crew size of 7. Well, they're just saying x equals 7. And that's all they're looking for there. Again, we can put that in the curly braces. Make that look a little bit more like a 7. And notice in C, they use that same notation, but they put a P outside. They're saying, oh, what's the probability? So find P of x equals 4 and interpret in terms of percentages. So in C, they say find P of x equals 4. Now, that's the very formal way of writing it. A lot of times you're just going to say P of 4. Each of those are very commonly accepted, and so you don't have to do the formal x equals 4 notation. So let's see this. So the probability of x equals 4, well, we're looking right here, of course. And to find the probability that it's 4, remember, it's f over n. F is the frequency, which they told us was 3. N is the total population size. Well, we have to add these up. We'll say a little sigma right here to say that we're adding them up. So I'm adding up all the frequency numbers. So let's see what we get. 4 plus 3 plus 36 plus 28 plus 63 plus 1. I get 135 missions. So the sum's 135. That's going to be my n. We'll just put it here so it doesn't get too far into anything else. But so this is 3 out of 135 missions had a crew size of 4. So if I do that, I'm going to get an answer of 0.02 repeating. So we'll go to 3 decimal places, 0.022. But as a percentage, remember, just move the decimal 2 places. So about 2.2% of the time, about 2% of the 2.2% of the missions had a crew size of 4. All right, so that's what that means. Obtain a probability distribution. So now what we're going to do is that 0.022 for a crew size of 4, we have to find the probability for all the different crew sizes. I'm going to write it this way. So I'll write it vertically instead of horizontally. So X, which is crew size, could either be 2, 4, 5, 6, 7, 8, and then I'll write P of X. So this is going to be the probability. And we already know for 4, it's 0.022. But for 2, now remember there, for 2, we'll put that in blue. In 2, we had a frequency of 4. So we're going to say, oh, this one's going to be 4 out of 135. This for a crew size of 5 will be 36 out of 135. And we'll just continue to do that to get the values. But that's where that probability number is going to come from. So let me just do these in my calculator real quick. 4 divided by 135, I get 0.0. It's this, 0.0296. I want to go there. But the number next to it to the right is a 6, which is 5 or larger, so I round up. So instead of 0.029, it's going to be 0.030. Okay, so that's what I'm going to put in. And I'm just going to calculate the rest of these. So let's see, the 36 divided by 135, 0.267. Let's see, the next one was 28 divided by 135. 0.207. For 7, it was 63 divided by 135. So 0.467. And then that last one, the frequency was just 1. So 1 divided by 135, 0.007. Now, I'm going to add these up as a check. It should add up to 1. Since we're to the 1,000th, the 3rd decimal place, we may be off on that last decimal place by 1. So it may be 1.001, might be 0.999. Those would be fine. If you're any further off than that, check your math. You shouldn't be. So let's see. So I'm going to do those rounded numbers. So 0.03 plus 0.022 plus 0.267, 0.207 plus 0.467 plus 0.007, and I get exactly 1. So it just says 1 on my calculator. We could do the 0, 0, 0 if we wanted to. So we do get 1, which is what we want our probabilities to add up to. So anyway, that was D. And then E says, okay, now that you have all the probabilities, construct a probability histogram. Remember, with a histogram, we're going to line these up. All of the bars are going to touch because it's numeric data. Remember, with a histogram, they touch. With a bar chart, when we have non-numeric data, quantitative data, they're not going to touch, but these will. So I'm going to do crew size. Let's see, we'll do frequency up here. Well, not frequency, because they want us to do not frequency, but they want us to do probability. So I can't write sideways very well. Probability. Not too horrible. We'll put the crew size down at the bottom. And so I'm going to go 2, 3, 4, 5, 6, 7, 8. Notice I don't have any 3s, but I want to list these numerically. So I have to have a blank spot where that 3 is, since we didn't have any crew sizes 3. So let's go up. The biggest we have is 0.467. So I'm going to go up 0.1, 0.2, 0.3, 0.4, 0.5. Okay, so let's go up 0.03. That means we're only 3/10 of the way up to the 0.1. So not very high. The next one, 0.022. So that's even smaller than the first one. And was that right? Yeah, because we had 3 instead of 4. So it's a little bit lower, but it's way over here. Remember, there was none of the 3s. I went too high there. So we go up just a little bit, come over. That looks even higher than that first one was. It will make the first one a little bit higher. That one a little bit lower. I can't erase that very well. Let's try. Okay, I erased a lot of stuff there. Okay, there's 4. There we go, that's a little bit better. Do the best you can. 0.267, okay, now we're a little bit above, a little bit past 2.5. Maybe something like that. 0.207, so just over 0.2. Maybe here. 0.467, so this one goes up pretty high, over 4.5. And then the last one, 0.07, so it's really low. And then I like to just fill these in a little bit. And that just gives us a visual impression of what's going on. So we see this is definitely a left skewed graph. If we were looking at this, the peak is definitely far to the right, but we've got some left stuff pulling it off. We're going to make our average lower than our median for sure. Okay, so anyway, that's the idea. That's pretty much the end of this section. Do notice one thing, that our sum of x, we'll put it over here so it looks better. Our sum of x was equal to 1. The sum, I said sum of x, I meant sum of p of x. Let's erase that so we can fit it in a little bit better. So the sum of the probabilities do always have to add up to 1. We'll put that as a quick note right here. No, I still wrote that wrong. The sum. That's horrible. Let's try that again. That's supposed to be a sigma. The sum of p of x is equal to 1. So do realize that. Okay, from there, let's jump into the next section. We're going to do some computations with these. So we're going to go into the mean and standard deviation of a discrete random variable. Okay, let's just start off with mean. So the mean, again, the mean is just the average, but the way we're going to find these is a little bit different. What we're going to do is we're going to take all of the x values times their probability. and then we're just going to add all those up. Now the book doesn't put a bracket here, but I like to, because sometimes I'll find my students will add up all the x's and then multiply it by p of x, which they typically just pick the total, the sum, and then all you have is really the sum of the x's, but it's each x times its probability, and then you add all those up. Okay, sometimes they'll call this the expected value, or even the expectation. And in fact, what they do here, this is mu, or sometimes they'll even call it mu of x, mu sub x. So it's just the sum of x times p of x. Again, I'll put the bracket here, but that's my formula. So that's my mean, it's population mean. Okay, so we've got that. What it's going to represent is the average that we would expect in a large number of trials. And we'll talk about that a little bit more when we do an example, but let's also talk about the standard deviation while we are writing formulas down. Now the standard deviation, sigma or sigma sub x, if you want to put that subscript of x there. And there's two ways to do it. One, so that it looks like our defining formula for standard deviation before. We could do all the x minus mu, which we had just calculated, square those times p of x. So very similar to what we were doing before. Then we would add all those up. Typically though, the way they're going to do it to make the calculations easier, and then it would be the square root. It's the variance if we don't take the square root. And then the other way that we're usually going to do it for calculations to make our calculations easier, it's going to give us the same value as above. So it's an equivalent formula. It's just x squared times the probability p of x. Add all those up, minus mu from above, squared, and then take the square root. So that's the one that we're going to use as a formula. Let me box that in blue so it doesn't get confused with the square root symbol. And so there's our mean, there's our standard deviation. And again, the standard deviation means what it always does, it's how far on average our data points are from the mean. And we'll use that when we do a problem. We'll talk about that specifically. Okay, so let's jump in and grab a problem. So it's going to be 537 out of the book. I just need to copy that real quickly. There's 537. We will copy it. And we'll go paste it back in. Okay. So back into OneNote. I'm a big fan of OneNote. Archery. An archer shoots an arrow into a square target 6 feet on a side whose center we call the origin. The outcome of this random experiment is the point in the target hit by the arrow. The archer scores 10 points if she hits the bullseye, a disc of radius 1 foot center at the origin. She scores 5 points if she hits the ring with inner radius 1 foot and outer radius 2 feet centered at the origin, and she scores 0 points otherwise. Assume that the archer will actually hit the target and is equally likely to hit any portion of the target. For one arrow shot, let S be the score. A probability distribution for the random variable S is as follows. So if we want to see a picture of this, what we have is we've got this target that the archer is shooting at, and within there, there's a couple circles. There's the bullseye, and anytime you hit in the bullseye, you get 10 points. There's another ring. Anytime you hit in that ring, you get 5 points. Oops. And anytime you hit outside of that, you get 0. So that's the picture of what's going on here. Okay, so they give us the probability distribution. So the random variable S is the score, either 0, 5, or 10, and the probability of each of those. So A, on average, how many points will the archer score? Well, the average, that's the mean. So this is the mean. So we're looking for mu. So let's calculate. I'll calculate it. Oh, we'll calculate it down here so that we have plenty of room. So for part A, the mean is the sum of x times its probability. Now, these are S's. Let's go ahead and change those to S's so that we have them. S times the probability of S. All right, that's good enough there. My S's kind of look like 5s, and I apologize for that. Those are both S's, which is why I like to use X. Of course, they're using S for score in this case. So either we scored 0 and we multiply it by the probability of 0, which is 0.651. Plus, we could have scored 5. We multiplied that by the probability. Let's put those in parentheses. 0.262. Plus, we could have scored 10, and that probability is 0.087. And that's all we do. We add all those up. So let's do that. Notice that first one, 0 times something. I'm not even going to put that in my calculator because it's going to come out as a 0. When I add it to the next number, it doesn't change the next number. So I've got 5 times 0.262 plus 10 times 0.087. And I get 2.18. And so what this is saying is on average, the archer will score 2.18 points per shot. So let's word that on average. The archer will score 2.18 points per shot. Now, can the archer score 2.18 points per shot? Absolutely not. The archer can score 0 or 5 or 10. So when we get an average, that's not what we would expect to get on one shot, but it's the average we would expect to get if we have a large number of trials. The larger the number of trials, the closer we expect the average of those trials to get to 2.18 as the average points per shot. Okay, so that's the idea of the mean. B says obtain and interpret the standard deviation of the score per arrow shot. So B, now let's go back to the formula we had before. And the formula looks like this. I'll put it in terms of X's, but then we'll just change it. So it's the sum of X squared times P of X minus mu squared, and then the square root of that whole thing. Well, we're in terms of S, so it's the sum of S squared times P of S, and then minus mu squared. And then again, take the square root to make it the standard deviation instead of the variance. So let's go through and calculate this. Now, these are small enough. I'm just going to write it out as a big long string of these. So I'm going to say, okay, the standard deviation. Remember, we're doing S squared. Well, that's 0 squared times 0.651 plus squared times 0.262 plus 10 squared times 0.087. And that's that first piece, my first summation, minus mu squared, that's my 2.18 squared. And then I'll take the square root of all that. So I can just put it all in my calculator at one time. If you want to do this as separate pieces, you can, but I'm just going to put in my calculator. I'll tell you as I go. I'm putting in square root. Now I need an extra parentheses for this bracket right here. It opens up in my calculator a parentheses to begin with, but that's going to be the parentheses essentially here. It's not very good parentheses over there. So I'm an extra parentheses. Again, the 0 squared is just 0, so that first piece is going to go to 0. So you can type that in or not. It's not going to change your value. I'm actually just going to put in 5 squared times 0.262. I'm not putting in an extra parentheses for the times 0.262 because the calculator knows the operation. It's going to multiply those before it does the 10 squared times 0.087. So it'll do all those multiplications and exponents before it does the addition anyway. And then I'm going to close that parentheses because that's that first piece. So I've done that with a closed parenthesis. Open and then close the parentheses. Minus 2.18 squared. And then I can close the parentheses to close out the square root if I want to. You don't have to close it out. It will do it automatically. But I get 9.42 if I round to the nearest 3 decimal places. Oh, 9.423. Now, these are points scored. So typically what we do when we do a calculation is we round to 1 decimal more. I know I rounded it. I went to 2 decimals more previously. The reason for that kind of twofold. One, it was exactly 2.18. There wasn't any other decimals that I rounded to. But 2, since I'm using that number later and I want to round to 1 decimal place, it's good to go to 2 decimal places in the interim. So if I round this to 1 decimal place, I get 9.4 points. And then let's interpret what that means. That's our standard deviation. So we would say something along the lines of, on average, because remember it's an average, each shot scores about 9.4 points away from the mean of, what do we have, 2.18 points. Now, in my mind, I'm thinking that value looks a little big. So let me redo that calculation real quickly, see what we get. So let's see, I think all my numbers are in there right. I'm checking them real quickly. So let's do that. And always check to make sure it makes sense. That to me just sounds too big. So let's see. I'm going to do that calculation on the inside again. So let's do 5 squared times 0.262 plus 10 squared times 0.087. So I've got that. And then minus the 2.18 squared. And then what? So that 9.4 is way off because I get a 10.4976. I haven't taken the square root yet. So now if I go square root of that answer, I get 3.24, which makes much more sense to me. So let me erase that here. I get 3.24. Again, check these to make sure they make sense. And so now I can change that answer. Again, if I go to 1 decimal place, I would just say 3.2. And that makes more sense because if I'm usually scoring 0 points, 65.1% of the time I score 0 points. So if the average is 2.18, I'm almost 3 points away. Sometimes I score 5, which I'm going to be a little, almost 3 away. And sometimes I score 10, which I'm almost 8 away. So the 3.24 makes a lot more sense. And I'm just not sure what I did the first time when I did this. So let me see real quick if I can determine what I did. .24. I have a feeling what I did is I did that I probably didn't square the 2.18. I don't know. I'm guessing. But I did notice by knowing the definition that value seemed too high. So do make sure you check things like that. Okay, let me show you one more part. It wasn't actually part of this problem, but I want to throw it in. We'll call it part C just for fun. But here's a question that often comes up. How many points would we expect in 20 shots? So we're looking for the total number of points in 20 shots. Well, remember, if on average we score 2.18 points, all I'm going to do is we're going to say, oh, 20 times I'm going to score 2.18 points. And so I just multiply those together, and I'll say 20 times 2.18. I get 43.6. Well, since it's the number of points, I usually round that to the nearest point, since this is specifically saying, hey, how many points do I expect? I don't expect 43.6 points, so I would round that up and say about 44 points. So I would just round that to whatever the nearest whole number of points is, because I know I have to score a whole number of points. So anyway, we could use that for any number of shots. All right, so that's the gist of these two sections. This is a much shorter lecture than some of them, but we only did two sections. So hopefully it'll be easier to understand this. And as you do more problems, you'll obviously get more practice at it anyway. Okay, so with that, I will talk to you later. Make sure you do your homework and ask questions when we have a live session.